Hello, I'm Peter Boswell with the Atlantic Grains Council. Today we're demonstrating the calibration of a grain drill. Today's video is sponsored by the Canadian Agricultural Partnership Program, which is comprised of Agriculture and Agri-Food Canada, the governments of Newfoundland and Labrador, Nova Scotia, New Brunswick, and Prince Edward Island. I will be joined by Steve Hamill of the PEI Department of Agriculture and Lands to actually do the calibration. But I'd like to also thank the Atlantic Grain Council's checkoff partners and farmers from across Atlantic Canada for their sponsorship of the activities of the Atlantic Grains Council.
Today we're going to walk through the process of calibrating this grain drill so that when we head to the fields we can ensure we have accurate seeding rates. Properly maintained and well calibrated drill can help improve plant stands as well as help control seed costs. So the first step we want to do is to calculate our seeding rate, and to do that we want to base it on a target plant population per acre rather than sowing on in terms of a weight per acre or volume per acre, which does not account for seed size. Seed size is fairly important because it can change between crops, between varieties of the same crop, and has year-to-year fluctuations. Also, additives such as seed treatments and inoculants can affect the way the seed flows through the drill. Therefore, we always want to calibrate the drill with the seed we're using based on our target plant population, our seed size, and the germination percentage of the seed lot we're using. For today's demonstration, we will be seeding winter wheat, and to help us calculate our seeding rate, we're going to refer to these tables. Table 1, which is the recommended plant populations for crops in the land of Canada. So to use it, we go down until we find wheat, and it gives the target plant populations both in plants per meter squared and plants per acre. So you can see wheat, 375 to 450 seeds per meter squared, or 1.5 to 1.8 million seeds per acre. I prefer to go on the high end of the range, so for today we're going to be setting the drill for 450 seeds per meter squared, or 1.8 million seeds per acre. Referring to our seed tag, we can see the seed we're using has a seed size of 13,000 seeds per pound. So then we go down to table 2, which is the seeding rate chart for cereal crops, and along the top axis here we have the target seeding rates per acre, both in seeds per meter squared and in seeds per acre. And along the vertical axis we have the seed size, which is given in 1,000 kernel weight, and the seeds per pound. So to use this chart, along the top axis you find your target population, so in this case it's 1.8, and then we go down the vertical axis to find our seed size, which was 13,000. So we're going to be in here somewhere. So then you just follow the lines across until they intersect. So we're going to be aiming for between 160 and 151, so we'll say 155 pounds per acre is where we're going to set the drill. And just to note, this chart does assume a 95% germination rate and a 5% mortality rate. If you would like to be more precise than that, you can actually plug your information into the seeding rate formula. So now that we got our seeding rate determined, we can get ready to calibrate the drill. In order to do that, there's a few tools that are required. We will need a floor jack or hydraulic bottle jack so we can raise the drive wheel. We'll need a fiberglass measuring tape so we can measure the circumference of the drive wheel, and duct tape or a permanent marker or something that we can mark it so we can easily count the revolutions. We'll need a standard measuring tape to determine the row spacing, Ziploc bags for seed collection, a scale that weighs in grams, and some containers for seed. So the first thing we need to do is lower the drill into the field position. So now we want to jack up the drive wheel so we can easily rotate it by hand. So the next step, we need to determine the circumference of this drive wheel. Peter, you mind giving me a hand? So this drive wheel is 8 feet and 8 inches, or 104 inches. So we'll use that number to determine our strip length when we're doing our calculation. Now we need to determine the width of the drill and the row spacing. So in order to do that, we take our standard measuring tape and we measure between the 2 runs of the drill, and it's 15 inches. But as you can see in this drill, the front gang is offset on the back from the back gang. Therefore, this drill is a 7.5 inch row spacing. And we count the number of rows, and there's 24. So that makes this a 15-foot drill. So we're up here on the top of the drill under the seed lid where the manufacturer suggested rates are. We're seeding wheat, and we know we want 155 pounds. So that'll be in here. So we're gonna set it initially at 30 for the test and see where that gives us. So now we're on the front side of the drill. We're gonna get it prepared for our test. So we're gonna remove the hoses that we're gonna test, which we determined we were gonna do 4. And when you're up here, it's also a good idea to check your seed cup to make sure it's in the appropriate setting for small grains, which in this case is the lowest setting, so it is. And then we're going to move this lever to our initial setting, which we determined was 30. Sometimes there can be a lot of play in these levers, so it's nice to go past your target both ways and then settle back in at your target, which is 30. So now we got that set. We're gonna load seed and prime the drill and hang these bags. Now that we got the grain drill prepped, we can determine how much seed we need to collect from each run in order to achieve our target seeding rate. In order to help us with this, I printed off this calibration worksheet from Atlantic Grains Council website, so we'll just start filling it in step by step. We count the number of rows, and there's 24 rows on this drill. The row spacing in feet, so we measured in inches, which was 7.5 inches, so divide that by 12. That gives us a row spacing of 0.625 feet. So the total width is A times B. A is 24 times B, 0.625. The drill width is 15 feet. And we took the tire circumference, which was 104 inches, divided by 12. Equals 8.67 feet tire circumference. Now for the strip length, we have to determine how many times we're going to spin the wheel. I like to do at least a minimum of 100 feet. So if we take 100 divided by 8.67, we got to go 11.5. So we'll go 12 wheel rotations. And our strip length is going to be E times F. So E is going to be 12 multiplied by D, which is our tire circumference, 8.67. So our strip length is going to be 104 feet. Now we can determine the seed we need to collect from each row to equal our seeding rate. And to do that, we predetermined we were shooting for 155 pounds per acre. In order to determine that, we got to follow this calculation. So we take D, which is 8.67 0.67 multiplied by B, which is the row spacing of 0.625, multiplied by E, which is the wheel rotations of 12, multiplied by G, which was our target seeding rate. Divide that by 43,560, which is the number of square feet per acre, and that gives us how many pounds we need to collect per row. So we will convert that to grams by multiplying by 454. So we need to collect 105 grams per row to equal 155 pounds per acre. And we decided we were going to test 4 rows. So times 4, we need to collect 420 grams of seed in the 4 rows to equal 155 pounds per acre. So let's head over to the drill and do our first test. So we loaded seed into the drill and we spun this tire to prime the rows so we know there's seed coming from each drill run. So now I'm just going to take this piece of tape to mark the tire so I can easily count how many wheel revolutions I do. So now we'll spin her 12 rotations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we'll move back to the front side of the drill, collect our bags, come in here and weigh them and do some math to see where we're at. So I'm just going to remove the bags from our first test, take them around and see what rate we have. So now we'll turn on our scale. We want to weigh our container that we'll be using and zero it out to make sure we're only weighing the seed that we collected. We have 82 grams and we were shooting for 105 grams, so right away we know we're a little bit light, but we'll dump the rest of them out, do some math to find out exactly where we're at and see how much we need to adjust the drill. $326 grams. So now we can calculate our seeding rate, and the first step of that is we need to figure out the effective drill width, which is I times B. So I is the number of rows we tested, which is 4, and B is the row spacing by 0.625. So our effective drill width is 2.5 feet. So on the first test we used a drill setting of 30. We collected 326 grams, and we'll need to convert that to pounds. So 326 divided by 454 equals 0.72 pounds, and then we run it through the seeding rate equation. So K, which is 2.5, times F, which is 104, 260. So now we go 43,560, the square feet in an acre, times M, which was 0.72, divided by our 260, and that gives us a seeding rate of 121 pounds per acre. We were aiming for 155 pounds, so we're light. So we'll have to readjust the drill and run the test again. Ideally until you're within 2 to 3% of your target range. So the calibration process is trial and error. So we were light on our first test, so now I'm going to open this seed mechanism a little wider, and then we're going to rerun the test to see if we can get it closer to our target rate. So we're at 37 this time. So we run the test again. I'm just going to weigh the seed, make sure my scale's zeroed. That time we had 425 grams and we were looking for 420, so we're fairly close, but we'll run the numbers and see exactly what we have. So that time I was on drill setting number 37. We had 425 grams of seed, so we'll convert that to pounds. Divided by 454, we had 0.94 pounds. And we'll do the math. 43,560 times 0.94 divided by 260 equals 157 pounds per acre. And our target was 155, so that's within our 2 to 3% range. So we're happy with that, so we'll just leave it there. So that concludes our grain drill calibration demonstration. I'd like to remind growers that the seeding rate can vary slightly in the field based on soil conditions, overlapping and travel speed. So please monitor your seeding rates as the planting progresses to make sure you're in that target range. Also, I think it's well worth the time and effort to do this procedure before heading to the field because it'll lead to better stands, better yields, and help control your input costs.
On behalf of the Atlantic Grain Council, I'd like to thank Steve Hamill of the PEI Department of Agriculture and Land for our assistance in this demonstration on calibration of a seed drill. I'd also like to remind viewers that the information and fact sheets and Excel spreadsheets needed to do the exercise are contained at the Atlantic Grain Council website and easily downloaded. With that, I'd like to wish everybody a good day and safe farming.